Welcome, ladies and gentlemen. May I have your attention, please? Thank you. Let's go ahead and get started. So we saw from last time, right, that we can take an expression and we can multiply individual polynomials together. And number one, this is just a review, kind of a warm-up back from Unit 3, where we take, in this case, we take some quantity, 3a to the 5th b squared, and we cube it. So think back to our rules, right? If there are parentheses, then we know every factor inside of those parentheses is going to be raised to the 3rd power. And so this is a case where we can distribute, right, the exponent into each factor, versus addition or subtraction, we cannot distribute the exponent inside the parentheses. So let's go ahead and take 3 and we'll cube that, and so that'll give us our 27. A to the 5th, remember our shortcut operation, when we take a power and raise it to a power, we get to multiply exponents. So this is not a to the 8th, it's a to the 15th. And b squared all cubed, right, isn't b to the 5th, it's b to the 6th, because we're multiplying exponents. Go ahead and raise your hand if you had that already. So 27, a to the 15th, b to the 6th, way to go, you guys. So those are our exponent rules back from Unit 3. Now let's go ahead and take a monomial factor, right? A monomial factor is a special word for just saying a single term.
Good morning, Abe. Please excuse the interruption. At this time, I ask that the members of the junior and senior class please report to PAC for the brief class meeting on the contact time information. Again, juniors and seniors, please report to PAC. At this time, we'll be about a 20-minute assembly, and we'll get you back to class. Thank you.
We'll go ahead and distribute that through using, you guessed it, multiplication. So our first multiplication will be negative 4m times 5m cubed, looks like negative 20m to the, and now we are going to add exponents. 1 plus 3 is m to the 4th. Next term, we'll go ahead and grab onto that negative 4m again and distribute it through the parentheses. Negative 4m times negative 6m is plus 24m squared, and lastly, that negative 4m times the positive 11 all the way through, then is negative 44m. And so last time we saw that when in standard form, a polynomial has the highest exponent term first, and so this negative 20m to the 4th is the highest exponent term, and then descending order after this. And so this is an example where we have a polynomial in standard form. Remember, a polynomial is just a collection of power terms connected by addition or subtraction, where all my exponents are whole numbers, right? No negative exponents are allowed, and no fractional exponents are allowed. But all these exponents are whole numbers, and so this is a polynomial. All right, so raise your hand if you had number 2. So did anybody get number 2? You had a lot of practice like this on your worksheet. It looked a lot like this. Good job, you guys. Number 3, oh goodness, so I've got a couple different distributions going on here. We're going to go ahead and do the same thing. So here we go, outside monomial. Factor 2, we're going to multiply that into my parentheses, so it looks like we've got 2x squared y plus 6xy minus 14y squared. And now we'll go ahead and continue the party. Remember, this negative sign belongs to somebody. Does the negative sign belong to this first polynomial in parentheses or the 3? Well, it belongs to the 3, and so we're going to distribute that negative 3 through the second set of parentheses in blue, but we're going to keep track of our signs the entire time. It'll always be negative 3 times. So negative 3x squared y plus. Negative times a negative is a plus, so everybody make sure you see where that plus comes from. Plus 12x cubed y squared, and then minus, looks like, 6y squared. All right, be ready because I'm going to be calling on you. I want you to identify a pair of like terms, that is, variable components match exactly in order to combine. So everybody look, I'll go with Gadgerman. Everybody, we want to decide a pair of like terms. So what's one pair? Katie?
Can I ask a question?
Yes.
On the 12x cubed y squared,
yes.
Where did you get the cubed and squared?
I'm sorry, it should just be, I'm distributing x here. It should just be exactly the same kind. That's my mistake. I apologize for that. So it should just be negative 3 times negative 4xy gives us positive 12xy. When we multiply, we don't change, right? We don't change. There are no variables on that 3, and so it's just going to be a positive 12xy. Sorry about that. Is that right now? Is everybody good? Okay, thank you. I appreciate that. So everybody pick out a pair of like terms. Be ready to share when I call on you. So what's one pair of like terms here that I could combine through addition or subtraction? Adam?
2x times -3.
Good, thank you. And so 2x squared y minus 3x squared y, those are like terms because they're both x squared y terms. So I can combine them simply by adding the coefficients. 2 plus a -3 is -1. So it looks like this is -1x squared y. Tell the class a different pairing of like terms when I call on you. Carson?
6xy and 12xy.
Thank you. So 6xy and 12xy combined, we get plus 18xy. Awesome. And then any more like terms, Caitlin T?
-14y squared and 6y.
So -14y squared, -6y squared. Thank you. Those will combine together to give -20y squared. It looks like we got it all now. Go ahead and raise your hand if you had that already. So did you make it to the end with the correct signs? Well, that's great, you guys. And so this is one of the trickier ones. Nice job. I'll go ahead and box that. Okay, and then the last thing is when we take two binomials and multiply them together, right, from last class. A binomial is just a fancy word for a two-term polynomial. And so that's when there's two terms combined by addition or subtraction. X and 3, that's two different terms combined by addition or subtraction. X plus 3, that's a binomial. X minus 5, X and 5 are two terms combined by subtraction, right? And so that is a polynomial, it's a binomial, two terms. All right, let's do a binomial times a binomial. And so we can go ahead and grab onto that first factor. In this case, the X. Cover up the plus 3 and just distribute that X through the second set of parentheses. Here we go. X times X. I got that. X squared. That's the funniest looking arrow I've ever seen. X times -5 is minus 5x. Now we've distributed that x through the second set of parentheses, term by term. Now we're going to go ahead and cover that x up and focus on this squiggle underline, or double underline 3. So now we're going to go ahead and focus in on that 3 and distribute that through the second set of parentheses. Here we go. So my first distribution will be 3 times x is 3x. Positive. And then lastly, it would be positive 3 times -5 is minus 15. So minus 15. Go gadget arm. And standard form, we're not fully simplified, right? Who spots why we're not fully simplified? How come this isn't all the way simplified? Barrett? Absolutely. What pair of like terms?
-5x.
Absolutely, thank you. So my final answer then would be x squared minus 2x minus 15. Strong work, and I'm thinking the blue box is really going to set that up. So raise your hand if you already had number 4, all the way at the end. That's great, you guys. Okay, so we know that you can multiply in a variety of situations. Today we're going to continue our multiplication. We're also going to look at some graphs. And we're going to look at naming or classifying polynomials, but that one all fit here along with our schedule and our stamps. And so we're really going to graph, multiply, and classify polynomials. But I just put multiply because that'll be the bulk of our discussion. Okay, at this time I ask that you go ahead and take out your worksheet number 1. It's out of 36. It should already be stapled. If you show me your reading questions, 11.1 and 11.2, we'll lump those together and be the reading questions, the additional point for your assignment number 1. If you did one reading question, it'd be plus 0.5. If you did both reading questions, it'd be plus 1. I'm going to go ahead and pause the recording while we do our check. So make sure that you give yourself an infinite campus score, please. And round that to the nearest half point in pencil. Okay, ladies and gentlemen, thanks for focusing back in on our content objectives today. We're going to describe characteristics of polynomials. We're going to take a look at some graphs of polynomials. We're going to multiply polynomials, and we're going to classify them. So we're doing a little bit of naming, okay? Some naming today. And so we saw from last time with the recording that standard form arranges my polynomial, right, in highest exponent first, and then decreasing exponent terms come after that. The coefficients are the multipliers on there. This is from last time. It's on your sheet. Just reminding you, the leading coefficient is on that highest exponent term, right? And we'll see that later. And then the constant term is the one without a variable multiplier. So it's just the minus 11 or the the plus 17, okay? So we're gonna look at this a lot. Sometimes a polynomial appears, a given type of polynomial appears so frequently it gets its own shortcut name. So like, you already know y equals mx plus b. This is a polynomial because it's x to the first. That's a whole number exponent. And that's a linear. Quadratic is when we have a squaring term as the highest exponent term. It may or may not have additional terms. Cubic, quartic, quintic. We don't necessarily use quartic and quintic very much in our discussions in advanced algebra, but you'll see them more later. Let's go ahead and take a look at a couple basic graphs. So 1 and 2, we're going to do them by hand, and then 3 and 4, we'll use your graphing calculator. So let's go ahead and take a look and review some polynomial graphs. You've already seen throughout Unit 2 our linear polynomials. We know in general we could go ahead and plot our y-intercept. Our y-intercept looks like 0, 3. And then count out our slope number, our rate of change number as a fraction rise over run to generate additional points on the line. So starting from my y-intercept value of 0, 3, I can count up 2 over 1, up 2 over 1, up 2 over 1. I can even count down and backwards if I was feeling so inclined, a little bit saucy. Then we can connect those with a nice saucy. So inclined, we can connect those with a, ooh, very nice. Line, and I know that you wish you had a line tool for your note sheet at your desk. That'd be pretty sweet. For a quadratic equation, we're going to spend time next semester. Our very first unit, Unit 6, deals with how to graph quadratic equations, right? Efficiently by hand. Right now, we can simply make a graph by doing our XY table of values as we've done in the past. And so we'll just go ahead and choose the same XY points to get a nice picture. Let's go ahead and do X values of -2, -1, 0, 1, and 2, and simply evaluate my function rule to produce the corresponding output Y values and then plot them as ordered pairs X, Y in the XY coordinate plane. So when I plug in -2, guys watch your order of operations. -2 goes in for X. I square it first and get +4 before multiplying by the -2 up front. So it looks to me like I get -2 quantity squared is 4 times the -2 up front is -8, and then +9 is 1. -1 squared is +1, then times the -2 is -2 plus 9 is 7. 0 squared is 0 times the -2 is still 0 plus 9. 1 squared is 1 times the -2, and then plus the 9 again is 7. On the folder. So we've got 7, and then lastly 2 squared is 4 times the -2 is -8 plus 9 is 1. Everybody, let's go ahead and carefully plot those and connect them to make a nice parabola, right? The graph of a quadratic or squaring function. How's that? Can you get them all? All right. This looks like an upside down parabola and very steep. Upside down parabola and very steep. Awesome. What questions do you guys have about our linear or quadratic? Let's take a look at a cubic. And so if we have degree 3 or higher, for 3 or higher, we're not going to have to do it by hand at this stage, okay? So what I'm going to do, in the interest of time, given our contact time assembly, is to go ahead and click the graph and ask you to focus in on this dominant term. That is the highest exponent term, the term that gives this polynomial its a shortcut name, a cubic function. What's the exponent on this dominant term? Right? What's the exponent on this dominant term? Jackson? 3. So is my exponent an even or an odd exponent? Logan? Odd. Notice how that has the same end behavior, the same behavior at the ends of the graph as my parent cubing function. It's got that down-up disco behavior because its dominant term is cubing. Now, it might have all kinds of squiggles in the middle, it might have less so and just kind of do a little bend, right? But at the end of the day, it behaves like a cubing function with the down-up opposite end behavior the way we saw back in Unit 1. Let's go ahead and take a look at the next one. Again, I'm not going to do it on the emulator in the interest of time. I've already inserted the graph. What's the dominant term on that fourth degree function? What's the dominant term there? Everybody find it. Carson?
20x.
Oh, the highest exponent term. The highest exponent term is which one?
X to 4.
Absolutely, that x to the fourth. Is that dominant term have an even or an odd exponent? Katie?
Even.
An even exponent. Guess what? Even though we haven't graphed fourth degree polynomials, right, yet, at the ends of the graph, it has up end behavior, just like a squaring function, right? Just like an even power function that we've seen back in the past. An even power function is going to have that up end behavior, or if it was a negative multiplier in front, it would be opposite orientation, it would be down. But they're same. That even behavior is that same in behavior on the far left and right. So here we can have this up. It's also interesting to note that these quartic polynomials, fourth degree polynomials, a lot of times look like W's. They end up looking like W's, right? Sometimes it's kind of a droopy W, or one side is a lower dip than the other, a lower value, and then they're kind of like, I think of those, is that Salvador Dali, those melting clocks? Have you seen those melting clocks? No, yeah, it's kind of like droopy W's, I think of them. Awesome. Okay, so let's go ahead and do a little practice with naming, classifying, then we'll do some multiplication, and then you'll have some work time. So here we go. Let's rewrite this in standard form. Recall, to be in standard form, we must be fully simplified. That is, any like terms should be combined, and the dominant term that we've been talking about, right, with Carson and Logan and Jackson, the dominant term has to come first. So everybody, let's scan this problem and see, are there any pairs of like terms, right? Are there any pairs of like terms? Eric?
Oh, yeah.
Where? Who? Which? When?
That's negative 8x squared and 3x squared.
Excellent. So we've got negative 8x squared and 3x squared. Any other pairs of like terms? No other pairs, okay. And what's the dominant term here? So we gotta scan the problem and find the dominant term. In standard form, bless you, that has to come first. So what's the dominant term here, Heather? Good, so that's gotta come first. And so we'll go ahead and rewrite in standard form. We've got 6x to the fifth. Then we'll go ahead and do the next highest exponent. Looks to be that squared term, so minus 3x squared plus a negative 8x squared is minus 5x squared. Is that what you guys are getting? Minus 5x squared. And then minus 47 at the end. And so now we're in standard form because we have fully simplified, any like terms are combined, and we've got highest exponent term first. That's called the dominant term. Now we can look at the degree and leading coefficient based on that dominant term. So it looks like our dominant term is there. Our degree then would be the highest exponent. That's degree 5. Or a quintic polynomial, we'll say degree 5. The leading coefficient is the multiplier on the highest exponent, and that is 6. Everybody see that? The constant term is the term that doesn't have a variable multiplier. So the constant term here would be the negative 47. Notice how we keep the sign. Notice how we keep the sign on my constant term. That negative belongs to somebody. It doesn't belong to the squaring term. It belongs to that constant term. Negative 47 is the constant term. Awesome. PDFable. We want PDFable. What questions do you guys have about our standard form? Great. I can't wait to check out this polynomial p of x. Again, a quintic polynomial. Goodness gracious. Degree 5. As I'm thinking about this, I don't know what the graph is going to look like in terms of all its maximums and minimums, dips, right, mountains, valleys, but I do know that it's an odd polynomial in the sense that it's not odd given a later definition of even versus odd functions in FST, but the degree of the dominant term, the degree of the polynomial is odd, and so I would expect the end behavior to be a down-up disco behavior, kind of like my cubic. Let's check. Ready? Ah, there we go. And so here, at the end of the day, right, even though this window is crazy, negative 3 to 3, but look at negative 120 for my y's, negative 120 for my y's, and 10 for my maxes. Look, at the end of the day, it still behaves like a down-up, an odd power function, a disco, right? A disco end behavior. All right, let's go ahead and find p of 2. And so p of 2 says, what's the value of the function p when my input, my x value is 2. And so to figure that out, we can simply rewrite my original. Except everywhere I see an x, I won't put x, I'll put 2. So we can do that algebraically. Uh-oh. It's going to be tough. It's going to be tough. Can we do it? Yes, we can. What's going to go in for x? 2 is going to go in for x. So everywhere p of 2 accepts inputs, we're going to put a 2. All right, let's go ahead and work it out. So it looks to me like 2 to the 5th is 32. 33 times 6 is 180. And 12, what is that, 192? Am I doing it? 2 to the 4th is 16 times 3 is 48. So minus 48. 2 squared is 4 times the 4 out front is 16. Minus 4 minus 70. It looks like that 48 plus 16 negative 32 plus 4 or minus 4 negative 36 minus 70 minus 106 92 86. Am I getting 86? 86? Woohoo! Lucky guess. Math is hard. Numbers are hard. That's why when in doubt, you just guess. You just throw out a number and then you hope it's right. No, I hope that you verify it with your calculator. Awesome. Great. An easier way? On my calculator, right? On my calculator, I could enter the function using that appropriate window and then press the trace button. I can trace the x value to entered, and if I've made that window, then the cursor will jump on the function, right? Jump on the function when x equals 2, and it will pair it with the y coordinate 86, and we can see that at the bottom of the screen. Again, because of our assembly, I'm not going to do that, but we've already done trace in the past when we were doing the fruit flies. That comes to mind, right? After 2 days, how many fruit flies were there? We did trace to enter, and it jumped on the graph, and so we're not going to do that now. Questions about our p of x function, our polynomial? Great. Then that's a printable for you. Now let's go ahead and practice classifying. And so here we're going to go ahead and classify some polynomials based on their degree and number of terms. And so a monomial is a fancy name for a single term. Kind of like when your advanced algebra teacher is so boring and he just talks in a single tone. That's called monotone because it's single. A monomial is a single term polynomial, like -7 or x to the 4th. Or even 6xy. 6xy is still a monomial. You might be thinking, wait a minute, it's got an x term and a y term. Nope, because it's a product. 6xy, that's a single term, right? It's a single term, it's a monomial. It's not connected with another term through addition or subtraction, which is how I separate the number of terms. Versus binomials, see how there's 2 terms connected with addition or subtraction, or trinomials, 3 terms connected by addition or subtraction. So a monomial doesn't mean just one variable, it means just one product of factors. All right, so let's go ahead and take a look. My monomial is one term. Can we state the degree of that? Certainly. The highest exponent determines the degree of a polynomial. And if the constant term, right, if the constant term is the only term in my polynomial, then its degree is 0. X to the 0 equals 1, and -7 times 1 would be degree 0. So my degree is 0 for that first monomial. X to the 4th, you guessed it, 4th degree. And if I have multiple variables in the same term, then its degree, the degree of that term is the sum of the exponents. And so the degree of this third monomial, 6xy, it's not 1. Even though that's x to the 1st and y to the 1st, it's the sum of those exponents. And so that would be 2, because there's an x to the 1st and a y to the 1st. Both contribute to the overall degree. The degree of 6xy is 2. The degree of a polynomial comes from its highest exponent term, right? Even there's multiple terms. And so look at the binomial, x squared minus 8. Now the highest degree exponent is 2 from any term. (3x plus 4y). Each term has an exponent of 1, but because they're separate terms, we don't add them together the way we did in the monomial 6xy. This is still degree 1, because the highest degree of any single term is 1. trinomials. Highest exponent term determines the degree. This quadratic trinomial has degree 2. In the final trinomial, right, I need to consider these variable terms. Y to the first, x to the first. This degree right here is degree 2. This degree right here is 3 plus 1 is 4. Which degree is bigger? The 4. Which gives us the polynomial's degree? The larger one. So 4 is the degree. Remember, the degree only comes from the highest degree term. It doesn't take into account all the terms. It just comes from the highest degree term. So the degree of polynomial of several variables is the largest sum of the exponents of the variables in any term, and we saw that. Now let's go ahead and do some multiplication. So x minus 7 times x plus 4, we saw that earlier. We're going to go ahead and grab onto this first term in that first binomial and multiply it through. X times x is x squared. Then we'll go ahead and do that x times the plus 4. I consider this my outer product. That's plus 4x. Then we'll grab onto this negative 7 times x. That's my inner product. I call that, and that's negative 7x. And then lastly, the negative 4 times, the negative 7 times the positive 4, I call that the product of the last terms, and that is negative 28. And so here I see a first, outer, inner, and last product, and we'll see that next class when we go backwards. We'll refer to this as the FOIL method. So here we had the first product, the outer product, the inner product, and the last product. That's going to be useful for us when we go backwards, when we undo multiplication in a process called factoring. And that's why I introduced it to you now. Now, if not fully simplified, oh no, what pair of like terms exists? Tyler?
The 4x and negative 7x.
Yeah, the outer and inner product are like terms, and so we can combine them and rewrite my final answer. Thank you. Let's go ahead and write my final answer then in standard form. So my standard form final answer would be x squared minus 3x minus 28. I'll go ahead and box that bad boy because Barrett, we want PDFable. We want PDFable, comma baby. Let's go ahead and try the next one. So we'll go ahead and do the product of the first term. So we'll go ahead and do 2x times x is 2x squared when I multiply. My outer product, 2x times negative 4 is negative 8x. My inner product, plus 1 times x is plus 1x. I won't write the 1 though to save digital ink. I'm trying to save the digital ink, so I'm not going to write the 1. You don't need a coefficient of 1 to be written. And then lastly, the last product, plus 1 times negative 4 is negative 4. Again, combine my terms. Sound effects, of course, are optional. And my final answer would be 2x squared minus 7x minus 4. And I'm thinking a red box is going to count nicely with the previous answer box. What questions do you have on our multiplication of binomials? Then can we up the ante? Can we raise the roof? Well, let's see. What if we take a trinomial times a binomial, right? We're going to go ahead and, thank you, Braden. Thank you. Got your back, too. Oh, yeah. All right. For reals, y'all. We're going to take a trinomial, a quadratic trinomial, and multiply it by a, in this case, linear binomial. We can do the same thing. We can grab onto one of those factors. Let's grab onto that x. And we'll multiply it through the parentheses term by term. So first we'll go ahead and focus in on this red underlined factor, the x. And I'll go ahead and distribute that through the parentheses term by term. Everybody's going to be multiplied by that x. Let's do it. X times 5x squared is 5x cubed. Then x times negative 4x is minus 4x squared. Then x times a positive 3 is plus 3x. And we're not done. Now we're going to go ahead and take that second factor, that negative 7. We're going to grab onto that, and we're going to distribute it through that first quadratic trinomial, term by term, using multiplication. So now we'll go ahead and focus on that double underline negative 7. Here we go. Negative 7 times 5x squared is negative 35x squared. Negative 7 times negative 4x is plus 28x. And lastly, negative 7 times positive 3 is minus 21. Get ready because you know I'm going to call on you. I need a pair of like terms here. What's a pair of like terms? Right? A pair of like terms? Margot?
Negative 35x and negative, negative 30x squared.
Yes, negative 35x squared and negative 4x squared. That will combine to give me a negative 39x squared. But I'm leaving room. I'm leaving room because in standard form, I want my highest exponent term first. I want that 5x cubed, the cubing term first, and I see it doesn't have any way to combine with. And so it looks like my 5x cubed will come first, then my minus 39x squared, and then another pair of like terms. Marina?
3x and 28x.
Thank you. So let's go ahead and combine that 3x and that 28x. That'll be, oh goodness, plus 31x. Is that right? Math is hard. And, just kidding. And lastly, minus 21. Awesome. So we're in standard form. A lot of love for math. A lot of love for math. All right. We're in standard form, so we're good to go. All right. So everybody go ahead and tell your partner what kind of polynomial is this, right? What kind of polynomial is this based on its degree? What kind of polynomial is this based on its degree? Okay, guys. So go ahead and tell the class the degree of this polynomial. What's the degree? What's the degree of this polynomial? Jackson and Olivia, just the degree. Absolutely, the degree is 3. This is a cubic polynomial. Raise your hand if you have degree 3 or cubic. That's the based on degree. Good. Next, what's the leading coefficient of this polynomial? The leading coefficient. Everybody get ready. What's the leading coefficient? Braden. 5 is correct. It's the multiplier on the highest exponent term. What's the constant term? Also the y-intercept when in standard form. What's the constant term? The constant term. Luke. Negative 21. Good job, you guys. Awesome. Let's go ahead and try another. When we have 3 binomials in a row multiplied together, oh goodness. What we're going to have to do is use the associative property of multiplication. And so what I like to do is pick any 2 to multiply together using our previous method, right? That FOIL or double distribution. And then lastly, we'll take the resulting trinomial and multiply it by that remaining binomial. So which 2 do you want to multiply together? Well, it doesn't matter. We can pick any 2 to do and then multiply them together. I think I'll go ahead and do, I'm going to go ahead and focus in on that x minus 3 times x plus 4. So I'm going to choose to multiply this blue pair, and I'm going to leave this x plus 2 alone for the meantime. I'm going to leave it right here. And then I'm going to go ahead and I'm going to multiply this blue together in one pairing. So I get x squared, outer product, plus 4x, inner product, minus 3x, and my last, minus 12. So notice how we've taken 2 of the binomials and multiplied them together using my double distributive property, or what we call as the FOIL method. You can see the FOIL. We'll combine like terms. Plus 4x minus 3x is just plus 1x. Minus 12. And now we're ready to do our mega distribution, right? So we'll go ahead and grab onto one factor now. We'll go ahead and grab onto our squiggle underline x factor. And what are we going to do? We're going to multiply it all the way through that second set. So let's try it. Here we go. X times x squared is x cubed. X times plus x is plus x squared. X times minus 12 is minus 12x. Go term. Now we're going to go ahead and take the second term in that first binomial, the positive 2, and we're going to, you guessed it, distribute it through term by term that trinomial. So here we go. 2 times x squared is plus 2x squared. 2 times x is plus 2x. 2 times negative 12 is minus 24. How do we do? Standard form puts the highest degree term first. Scanning the problem. Highest degree appears to be the cubic term. It doesn't have any like pairs, right? Like pairs, like terms to combine with. So we'll go ahead and start off the party with an x cubed. Then we need a pair of like terms. So what else? What like terms here exist? Brady?
X squared.
And
2x squared.
awesome, thank you. So we'll go ahead and combine those. That'd be plus 3x squared. Any other like terms? Cody?
Negative 12x and 2x.
Good, thank you. So negative 12x and plus 2x is negative 10x. Nice job. And a constant term, chilling last, that's negative 24. Beautiful. Love it. Totally saving these. Awesome. We are now at the time where you are going to show me you get it with your partner. So I want you to go ahead and, again, distribute that first factor through the set of parentheses. Distribute the second factor through the set of parentheses. Identify any pairs of like terms and write your answer in standard form. Pick one pair of binomials, right? Multiply together and then distribute, again, like the first problem. So go ahead and show me you get it with your partner. I'll be circulating around the room. If you have a question, please catch me with your eye and then we'll come back together to check. going. We'll come back and check in a minute. If you're still going, that's fine. Make sure that your electronic devices, cell phone, are off and away so we're free from distractions. We continue our multiplication polynomials. Great. Check it out. Nice roll. You guys getting this one? You guys getting the second one?
No, we did.
You guys are awesome. Guys, let's go ahead and come together and do a quick check. And so for our first problem that I wanted you to do with your partner was a binomial times a trinomial. And we can see by focusing on one factor in the binomial first and distributing it all the way through that second polynomial, and then focusing on the other factor in the binomial, in this case the plus 3 in blue, and distributing it all the way through, we can then combine like terms to get my final answer. Everybody, let's do a quick check. 2x cubed plus 9x squared plus 7x minus 6. Raise your hand if you and your partner generated that. So who else got that? Yes, yes, good, good. What questions do you guys have on this first one? When you have 3 binomials multiplied together in a row, then you can choose any pair of them, right, to multiply together first, and then do a problem just like the previous slide. And so I chose the second pairing. You could have chose the first pair, and then leave the last one on the back side. Either way is fine. I went ahead and multiplied the green together first, and then I did a problem just like the previous, the binomials and the trinomial. And then I finally combined like terms. Raise your hand if you had x cubed plus 2x squared minus 13x plus 10. Anybody else get that at the end? Several people did. That's great. Oh, awesome. Way to go. What questions do you guys have about the second one? Okay, then let's go ahead and box this bad boy and take a look at our closure for the day. So for our closure, that's printable, that's printable. For our closure today, we want to go ahead and classify each of these by their degree, number of terms, and leading coefficient. And so what I did is I made a template here. We're going to use this template to classify each of these. If we wanted to go ahead and classify each of these by their degree, number of terms, and leading coefficient, we could go ahead and identify this first one as a degree 3. That has a shortcut name. So degree 3, we could say third degree or cubic, I heard you guys say. So we could call this a cubic binomial because it's 2 terms, semicolon, with leading coefficient 4. Right? That would be a cubic binomial with leading coefficient 4. Remember, the degree comes not from the first term, but from the highest exponent term. And so I have to scan the problem before deciding on the shortcut name. Sometimes we don't have a shortcut name. In this case, the degree for number 2, our degree for number 2 is 2. That's a second degree polynomial, right? It's a second degree polynomial. Does that have a shortcut name? Yeah, that's quadratic. And so this is called a quadratic. Now you could just call it second degree and still get full credit on your test or quiz. You can call it second degree. All right, I'm going to call it quadratic because we see that all the time. We see quadratic equations all the time in advanced algebra. Quadratic, and it's 1, 2, 3 terms. That has a shortcut name too. That's a trinomial. So that's a quadratic trinomial with leading coefficient, not 11. The leading coefficient, right, comes from the dominant term. So the leading coefficient would be -7. That's the multiplier on the quadratic term. Number 3 is degree 1. That has a special name too. That would be a linear binomial, and its leading coefficient would be -1. Notice how that negative belongs to somebody. The negative doesn't belong to the 9, it belongs to the x. And that was the dominant term, so linear binomial with leading coefficient -1. When I have 4 or more terms, I just call it a polynomial. Right? I don't know if there's any sort of quadnomial or anything like that, so I just call it a polynomial if there's 4 or more terms. The dominant term here is the 2m to the 4th. And so this, to me, right, looks like a 4th degree, or quartic. You could say 4th degree is fine. Polynomial, I just call it a polynomial because it's got more than 3 terms. With leading coefficient 2, because the highest exponent term has a coefficient of +2. And lastly, recall that given a monomial, a single term polynomial, the degree is given by the sum of the exponents on the variables. And so that's not a quadratic polynomial. It's not a cubic polynomial. In fact, it's a 5th degree polynomial. So you could write 5th degree monomial, or we could write quintic if you're feeling especially saucy, as I am. I'm going to call it a quintic because that's a shortcut name for a 5th degree polynomial. And it's a monomial. It's a quintic monomial with leading coefficient 7. What questions do you guys have on your closure today? Casey?
So when it's a monomial,
When it's a monomial, the degree is the sum of the exponent. Absolutely. All right, ladies and gentlemen, please listen carefully. You're going to have a nice chunk of time to work on your worksheet number 2 first with a partner, okay? Or individually if you choose. Make sure the noise level is down. When you've checked your answer key, check your answers with the post answer key on the back whiteboard, then you're going to go ahead and come up to the front desk and you're going to get stamps at number 8 and number 6 from the first side. And then on the second side, you're going to get a stamp at first pattern and stamp at third pattern. Please do the worksheet first while you're still in here so you get stamped. And when you're done, then you may work on the book problems. Don't forget your reading question from the assignment sheet as part of your assignment number 2. So there are book problems, but I want you to do the worksheet first. Does that make sense? Awesome. Great work today, you guys. I'm going to go ahead and stop the recording and save it.